we will continue our theory with some examples now. The first would be the assessment of risks. So here the question is that the organic compound acetaldehyde is a hazardous compound. It is emitted from cigarettes, e-cigarettes, preparation of food during thermal degradation of fatty acids, candle burning, residential wood burning, and possibly during photolytic degradation of polymers such as polyvinyl acetate. So there are a lot of indoor exposure or indoor sources potentially of acetaldehyde in real life. Now a reference concentration of 9 micrograms per meter cube and a IUR of 2.2 into 10 to the power minus 6 per microgram per meter cube has been proposed for acetaldehyde at the US EPA's integrated risk information system. So here we assess the risk to a person who is inhabiting in different rooms of a house using values in different parts of the house in studies, and with an assumed time activity pattern inside the house. So we will this is the sources of acetaldehyde, so many and more, and we are using a range of concentrations that have been reported in different parts of houses in different parts of the world. These does not mean that every house has the same concentration. In some of the studies where possibly there were higher sources of acetaldehyde, that is where they have measured those numbers. But so these are ballpark numbers that have been measured in some settings. They may be high exposure settings also or low exposure settings. We have just borrowed the numbers. Does not mean all the houses have the same concentration. So we will have some inhabiting different rooms of the house using values in different parts of the house in different studies, and with an assumed time activity pattern inside the house, assumed to remain approximately same every day. We will assume a time activity pattern and we will assume that this is repeated every day for every year or our duration of assessment. This is done to simplify and illustrate the method of solving these kind of problems, and of course the student can take up further complicated problems outside the course. So this is the example of this time pattern. So the location is the bedroom and the measured acetaldehyde concentration in micrograms per meter cube is 15.8 and the time spent in hours per day is 7 hours. Then the living or dining room, the concentration is 14.3 micrograms per meter cube per day, time spent 4 hours. Then kitchen 8 micrograms per meter cube, time spent 2 hours. Then a person may be going to the office also. So it is a 5-day concentration that has been averaged over 7 days, and that is 6 microgram per meter cube, and the time spent in office is 8 hours. And then outdoors 1 microgram per meter cube and time spent is 3 hours. So the total will be 7 plus 4 11 plus 3 13 plus 8 21 plus 3 24 hours. So we have accounted for 24 hours a day. So now the question is, calculate the non-cancer and cancer risk for an exposure duration of 40 years and a lifetime of 70 years. Now given the same concentrations, how can one try to reduce their risk show using one example. Okay. So the first thing would be we will work with some maybe non-cancer risk. So as a recap, we can remember our effective exposure concentration was the concentration in any stay, any location, exposure time for that location in hours, 1/24 conversion rate, exposure frequency, how many days per year, and then exposure duration in years, and this is averaging time in days. So, and then our hazardous quotient was HQ, this is EC by RFC, cancer risk would be EC multiplied by IUR. So, we will take up our solution now. So, let me add a whiteboard. Now, our first thing would be to calculate different types of risks. So, let us say first we will take non-cancer risk. In this, first we will take, let's say, bedroom. So we have several zones and we have to get the equivalent concentrations for both or all of them. So first we will say bedroom, which we will note as 1. So we will have EC1 equal to concentration in bedroom multiplied by the exposure time, then a conversion factor between hours and day, then how many days per year, our exposure frequency, how many years in terms of duration, and then divided by averaging time. So when we put our values, we have C1 15.8 and time spent per hours 7. So 15.8 micrograms per meter cube, exposure time 7 hours per day, then conversion factor, this is days per hour, multiplied by exposure frequency. So how many days per year? So it is every day, so 365 days per year. Exposure duration 40 years and averaging time in days. So 40 multiplied by 365 in days. So our units will also be fine. So hour will cancel, year will cancel, day cancels, day cancels. And here also there are many common terms, 40 cancel, 365 cancel. So our exposure concentration would then be, so EC1 is equal to, we will get 4.61 micrograms per meter cube. So that is the first one. The second is living and our living / dining room combined, we are saying right now. So EC2, we will, instead of writing the whole equation, I will write the values now. 14.3 14.3 and hours is 4 multiplied by 4 hours per day into conversion factor into 365 into 10 multiplied by 1 by into 40 multiplied by 40 into 365. So this comes out to be 2.38 micrograms per meter cube. Then third is our kitchen. So EC3 would be 8 micrograms per meter cube and time spent is 2 hours per day. Multiplied by 2 multiplied by 1 by 24 multiplied by 365 multiplied by 40 multiplied by 1 by 40 times 365. So this is equal to 0.67 micrograms per meter cube. So that is kitchen. Then the next is office building. So EC4. Now office building, what is our concentration? It is 6 micrograms per meter cube and exposure time is 8 hours. So we will go 6 and 8. 6 micrograms per meter cube, 8 hours per day, 1 by 24 conversion factor. 365 into 40 into 1 by 40, 365. So EC4 will be equal to 2 micrograms per meter cube. Now to complete the whole daily pattern, we have the outdoor also. Outdoors. So let's say EC5 is equal to 1 microgram per meter cube concentration and 3 hours per day. 1 multiplied by 3 multiplied by 1 by 24 multiplied by 365 multiplied by 40 into 1 by 40 times 365. So EC5 will then become 0.125 micrograms per meter cube. So our total EC will be EC1 plus EC2 plus EC3 plus EC4 plus EC5, and this is 4.61 plus 2.38 plus 0.67 plus 2 plus 0.125. This comes to be around 9.79 micrograms per meter cube. So our EC value is, the overall EC is 9.79 micrograms per meter cube. So hazardous quotient HQ would be EC by R EC by R FC equal to 9.79 by 9. So this comes out to be 1.09. So actually this is greater than 1.0. So this is our non-cancer risk. The next would be to determine the cancer risk. So the procedure is the same, except the averaging time is now the lifetime. So we will go over this once. We have the cancer risk. So let's say first again bedroom, and EC1 would be 15.8 multiplied by 7 multiplied by 1 by 24 multiplied by 365 multiplied by 40 multiplied by 70 into 365. So averaging time is actually now 70 years. So 70 into 365 days. So EC1 will then equal to equal to, so here only what terms will cancel? 365 and 365 will cancel. So EC1 will become, I'll just calculate as well, 15.8 multiplied by 7 by 24. So this will become cancel the common term only. So 15.8 multiplied by 7 multiplied by 40 divided by 24 divided by 70. So it is 2.63. Should I change? Okay. The next is our living / dining room. So EC2 would be 14.3 multiplied by 4 into 1 by 24 multiplied by 365 multiplied by 40 multiplied by 1 by 70. 70 multiplied by 365, and this gives EC2 is equal to 1.32. We'll just calculate that. So 14.3 multiplied by 4 multiplied by 40 divided by 24 divided by 70. So 1.36. So that is our EC2. Then we will quickly calculate all the other ECs. Third will be kitchen. EC3 is equal to 8 multiplied by 2 multiplied by 1 by 24 multiplied by 365 into 40 into 1 by 70 into 365. So same thing, except these two numbers will be different now. So this comes out to be EC3 is equal to 8 multiplied by 2 multiplied by 40 divided by 24 divided by 70. So 0.38. Then the next is, fourth one is office building. So EC4 is equal to EC4 is 6 into 8 into 1 by 24 into 365 multiplied by 40 multiplied by 1 by 70 into 365. So EC4 is 6 1.14. Then finally we have EC5. That's our outdoors. One into 3 into 1 by 24 into 365 into 40 multiplied by 1 by 70 into 365. So EC5 is now 1 multiplied by 3 multiplied by 40 0.07. So our total EC is equal to total EC is EC1 plus EC2 plus EC3 plus EC4 plus EC5, which is 2.63 plus 1.36 plus 0.38 plus 1.14 plus 0.07. So this is equal to 2.63 plus 1.36 plus 0.38 plus 1.14 plus 0.07. So it comes out to be 5.58. 5.58 micrograms per meter cube. So we have our EC now. Now we have to calculate the risk of exposure. So risk equal to IUR multiplied by EC. So that is our IUR is 2.2. Let's just confirm it. So IUR is 2.2 10 to the power minus 6. Multiplied by the concentration, that is 5 point. So this comes out to be 1.2 into 10 to the power minus 5. So this is basically one person in 10 to the power 5 similarly exposed person will develop a cancer, and from previously we remember HQ was 1.09. So the next question was, what if we want to reduce the risk? So of course we can reduce this, but here our goal will be to reduce HQ so that it becomes less than 1. So if we look at the different EC values, the EC1, or we'll go in next board. So we want to reduce HQ. So previously, let us note our EC values. EC1, EC1 was 4.61, EC2 was 2.38, all values in microgram per meter cube, and exposure times, here it was 7 hours, here this was 4, EC3 was 0.67, and exposure time was 2 hours, EC4 was 2, exposure time was 8 hours, EC5 was 0.125, exposure time was 3 hours. So this was our outdoor. This was the bedroom. And this was the living / dining. So these are the two places where we have the maximum contribution. So what we can do is, we will say that a person will spend 1 hour less here. So this becomes from 7 hours to 6 hours, and possibly 1 hour less in the dining and living room. So this becomes from 4 hours, this will become 3 hours, and this will then becomes, and the person spends, so this becomes 5 hours. So 1 hour each of bedroom and living room is now spent outdoors in playing an outdoor activity. So our revised EC1 would thus become, from 4 hours we have come to 6 hours. So our revised EC would be 15.8, you can recalculate it into 6. So this becomes 3.95. I'll just say EC prime. Then EC2 prime becomes 1.78. And finally EC5, because EC3 and EC4 do not change, EC5 prime will become, so now 3 hours have become 5 hours. So this becomes 0.21 approximately. And overall EC will become now EC prime, I will write 3.95 plus 1.78 plus EC3 and 4 are the same, so these are the same, 0.67 plus 2 plus 0.21. So EC prime is now 3.95 plus 1.78 plus 0.67 plus 2 plus 0.21. 3.95 plus 1.8 plus 0.67 plus 2 plus 0.21. So this becomes 8.61, correct? We can calculate with 3.95 just to double check, 1.78 plus 0.67 plus 2 plus 0.21. So our HQ will now become 8.61 by 9. This becomes 0.96. So from 1.09 we have come to 0.96. So this is less than 1.0. So this is one way we have obtained, or we have managed to reduce our hazardous quotient value. So this was a simple example. Next we will go to one case of the microbial risk assessment. So microbe X was found in indoor air of households. Its concentration was 30 CFU, colony forming units per meter cube. Assuming a person spends 5 hours in this environment before the window was opened and the concentration diluted significantly, calculate the risk due to infection given K is 1.65 into 10 to the power minus 5 CFU, CFU minus 1. This is The unit is CFU minus 1. CFU minus 1. K is 1.65 into 10 to the power minus 5 CFU to the power minus 1. And inhalation rate is 15 meter cube per day. So we will recap our equations. So we have to calculate a dose in CFUs, which would be concentration multiplied by inhalation rate in meter cube per hour, exposure time in hour, and then the probability of infection is 1 minus e to the power k times minus k times dose, where k is the survival probability of the single pathogen, our k value. So let us go for the solution now. So first thing would be the calculation of dose. So our dose is C multiplied by inhalation rate multiplied by time. So inhalation rate is 15 meter cube per day. So this is 15 by 24 meter cube per hour, and this is equal to 0.625 meter cube per hour. So dose then becomes, concentration was 30 CFU per meter cube multiplied by 0.625 meter cube per hour multiplied by 5 hours. So dose is equal to 93.75. So P, probability of infection, is 1 minus e to the power minus k times dose. So this becomes 1 minus e to the power minus 1.65 into 10 to the power minus 5 multiplied by dose. So 93.75. And P comes out to be then P is equal to 1.5 into 10 to the power minus 3. So let us say 1.5 of 1000 similarly exposed people will be possibly have the infection. So in summary, in this lectures we have covered the concept of risk assessment using average daily dose, reference concentration and inhalation unit risk as the matrix, and also we have looked at quantitative microbial risk assessment with some examples.